Hello and welcome to the Magic of Mathematics channel. My name is Manohar Murthy and you are watching one amongst a series of videos exploring the world of mathematics. In this video, I intend to show you how to find the largest perfect square that exactly divides a set of numbers. I will take an example for illustration. Say, we need to find the largest perfect square that exactly divides the numbers 810, 1134 and 2970. I will begin by observing that the largest perfect square that exactly divides a set of numbers cannot be greater than the largest number that exactly divides them. And we know that the largest number that exactly divides a set of numbers is the highest common factor or HCF of the given numbers. Hence, I will find the HCF of the given numbers first and see if it is a perfect square. If it happens to be a perfect square, we have the largest perfect square that exactly divides the given numbers. And if not, I will use the HCF as a base or starting point for finding the number that I am looking for. For finding the HCF, I will prime factorize each of the given numbers. 810 will prime factorize as 2 times, 3 times, 3 times, 3 times, 3 times 5. 11304 prime factorizes as 2 times, 3 times, 3 times, 3 times, 3 times 7 and 2970 as 2 times, 3 times, 3 times, 3 times, 5 times 11. For each factor in our prime factorizations, that is 2, 3, 5, 7 and 11, I will identify its occurrences in the prime factorization where it occurs the minimum number of times. 2 occurs the same number of times in all the prime factorizations. So I will go ahead and mark its occurrences in the first prime factorization. 3 occurs the minimum number of times here. 5 doesn't occur in the second prime factorization and hence its minimum number of occurrences, namely 0, is in the second prime factorization. So I don't need to mark the occurrences of 5. A similar argument can be used in the case of 7 and 11 as well. Now I can find the HCF by computing the product of the identified occurrences of the factors. Or in other words, the HCF of the given numbers is 2 times 3 times 3 times 3. It is clear that if I compute this product of prime factors, I will get the HCF of the given numbers. I will now examine this product to see whether the HCF is a perfect square. For this, I will use the fact that if a number is a perfect square, its prime factorization can be grouped into pairs of identical factors. Examining the prime factorization of the HCF, we can see that these two 3's form a pair, while this 2 doesn't have the other 2 required to form a pair, and a similar logic applies to this 3 as well. Hence, this product, which corresponds to the HCF of the given numbers, is not a perfect square. This means that the largest perfect square that we are looking for has to be less than the HCF. But the number that we are looking for also needs to exactly divide the given numbers, or in other words, it's a common factor of the given numbers. We can obtain common factors lesser than the HCF by dropping factors from the prime factorization of the HCF. Dropping a 2 will give us the next highest common factor, but this 3 doesn't pair up still and hence we still don't have a perfect square. Instead of dropping the 2, if I drop a 3 instead, I will get the next highest common factor. If I examine its prime factorization, I have a 2 which doesn't pair up and hence this will also not work. The next highest common factor is obtained by dropping a 2 as well as a 3. Now we have only 2 paired up 3's in the prime factorization and hence this product, which equals 9, is the largest perfect square that exactly divides the given numbers. A closer look at what I did gives the method which can be used for solving such problems. Basically, we obtain the prime factorization of the HCF of the given numbers and form pairs of identical factors as shown to see whether the HCF is a perfect square. In case nothing gets left out in the pairing process, the HCF is a perfect square and we have the largest perfect square that exactly divides the given numbers. In case something gets left out, as in this case where the factors 2 and 3 got left out, we drop them and compute the product of what is left over to obtain the largest perfect square that exactly divides the given numbers. In this video, I showed you how to find the largest perfect square that exactly divides a given set of numbers. If you found this video useful, I would appreciate a like. Also, you can subscribe to my channel to be notified as and when I publish more such videos.